Welcome back to the first year studies. We were studying the classification of the elements in the previous video. Now let us go for the long form of periodic table. Long form of periodic table, which is also called as the modern periodic table. So this is based on the modern periodic law, which states that properties of the elements are periodic functions of their atomic numbers, not atomic weights. So this is based on the Moseley's experiment that the square root of the frequency of the X-ray is directly proportional to atomic number but not related to atomic weight. So based on this modern periodic law, we have this long form of the periodic table. The features of this long form of the periodic table are, there are 18 vertical columns called groups. So there are 18 groups, we can call it as. So these groups are numbered as 1 to 18 directly. You just remember comparison with the Mendeleev's periodic table. There were first to 7th, each consisting of two groups A and B. Totally it is 14. 2 into 7, that is 14. And the 8th group consisted of 3 elements each. So these 3 elements belong to 3 groups, that is 14 plus 3 is equal to 17. And at the time of Mendeleev's periodic classification, noble gases were not known and noble gases were shown direct separate place. That's why one more group with respect to the noble gases, that is 18 groups. So totally there are 18 vertical columns which are called as the groups. The first two groups, 1 and 2 groups, are called as the S block elements. Group numbers 13 to 18, they are called as the P block elements. In between, the group number 3 to 12, just count 10 groups. These are called as the D block elements. There are 2 periods below main periodic table, which are called as the F block elements. And in case of this S block element, there are 2 groups. In case of this P block element, there are 6 groups. In case of this D block elements, there are 10 groups. So totally it is 18 groups. 2 groups belonging to S block, 6 groups belonging to P block, and 10 groups belonging to D block. And in the D block, in the third group itself, all these elements belonging to F block elements are to be placed. So instead of having a 3-dimensional periodic table, we will be having these F block elements shown below the main periodic table. So this is about the groups which are the vertical columns. Totally 18 vertical columns which are called as the groups. And 7 periods. These are the 7 horizontal rows. Even in the modern Mendeleev's periodic table also there were 7 periods. Same 7 periods were considered. So these are actually given as a period number 1, 2, 3, 4, etc., which indicates the principal quantum number 1 to 7. 1s, 2s, 2p, like that we read the electronic configuration. Based on that one, we are having this 1 to 7, that is 7 horizontal rows, which are called as the periods. So in each period, in the first period, there are only 2 elements. Only 2 elements, which are nothing but hydrogen and helium. Hydrogen belongs to first period, first group, while helium belongs to the first period, 18th group. I will write the rough diagram and show you the actual periodic table of the modern periodic table or long form of periodic table. Second period contains 8 elements. Okay, lithium to neon. Third period also contains 8 elements. This is sodium to argon. We may have one question here. In the third period, actually we are having 1s2, 2s2, 2p6, 3s2, 3p6, 3d. We are having. Even though this d orbital is present in the third orbit, this electron in the 3d will be filled up only after the 4s. That is, after writing this 4s, we will write 3d. This we have already discussed in the atomic structure chapter. Based on the n plus L values, the energy level is decided. 4s is having n plus L value is equal to 4, while 3d is having n plus L value 5. Therefore, 3d is having more energy than the 4s. So, to write the electrons in the 3d, first we have to fill the electrons in the 4s. So, all those elements containing the electrons in the 3d should first contain electron in the 4s. That's why they will come in the fourth period rather than third period. That's why we are having only 8 elements in the third period. In the fourth period, there are 18 elements. Fifth period also has got 18 elements. Just observe, in case of the fifth period, actually we start with the 4f. But before that we have to write the electrons in the 4s, 3d, 5p, like that. Then the elements present in the fifth period are only 18. Then the sixth period contains 32 elements. 32 elements. So this sixth period onwards, we get this F block elements. In the sixth and seventh period, we are having F block elements. That's why there are only 2 elements in the first period. This is called as the shortest period. These 2 are called as the short periods. These 2 are called as the long periods. Long periods. This is the longest. While the seventh period contains about 19 elements and it is still incomplete period. There are some more elements to be discovered and they are to be placed in the 7th period. So up to this 6th period, they are completely filled up. First period, since it is having only 2 elements, it is called as the shortest period. Second period contains 8 elements, third period also contains 8 elements. Before this third period, up to third period, there is no any other element belonging to D and F block. That's why second and third period contain only 8 elements each. Third period, fourth period and fifth period contain D block elements. In between S block and P block, there are D block elements. 10 D block elements, that's why it is 18 and 18. When this sixth period starts, in the third group, we have some 14 elements belonging to this F block. They are to be shown in the same third group, but actually they are shown the separate position below the main periodic table. Similarly, 7th period also has got 14 elements belonging to F block. So they are called as the lanthanide series and actinide series. 6th period containing 14 F block elements, they are called as the lanthanide series. Then 7th period elements are called as the actinide series. Then coming to these particular names for the various groups, except the hydrogen, the elements belonging to first group elements, they are named as the alkali metals. Alkali metals. Second group elements are named as the alkaline earth metals. Alkaline earth metals. 13th group elements, they are called as the, actually they are beryllium, boron, etc. Boron, aluminium. 15th group elements, they are named as the nicosins. 15th group elements like nitrogen, phosphorus, etc. Either the elements or their oxides, they are actually forming the suffocations. Suffocating elements are named as the nicosins. 16th group elements are named as the chalcosins. These are actually ore forming elements. For example, oxygen, sulfur, selenium, tellurium, etc. They form the ores. That's why they are named as the chalcosins. 17th group elements, they are named as the halogens. Then 18th group elements, they are named as the inert gases. Inert gases are also named as the noble gases. Earlier they thought that noble gases do not participate in the chemical combinations. But later on, after studying various other properties, the elements like xenon, etc., they are found to form various compounds. That you will study in the second year course, that is noble gases. Then D block elements are named as the transition elements. These are named as the transition elements because when we move from left to the right in the periodic table, from first group to 18th group, in the middle we will come across the elements which are actually showing, some of the elements show properties of the metals, some of the elements show the properties of the non-metals. So there is a gradual variation from the metallic to non-metallic character. Some are amphiprotic in nature also. For example, zinc, etc. So they are named as the transition elements. Then F block elements, they are named as the inner transition elements. So this is one method of classification, that is into various vertical columns, 18 vertical columns called as the groups, 7 horizontal rows called as the periods, and based on that one we are having various elements in the different number of elements in the various groups. There is one more method of classification as metals, non-metals and metalloids. Along with this classification, we will go to the next trends in the various physical and chemical properties, especially some physical properties like atomic radius, ionic radius, ionization energy, etc. that we will take up in the next video. Thank you.